All right, we're going to be finding the distance and finding midpoint in this lesson. So we're going to start with finding the distance. Now, finding distance is easy if the points are next to each other or right on top of each other. So like 0, 2, and 5, 2. This is where 0, 2 would be. This is where 5, 2 would be. And we just literally count 1, 2, 3, 4, 5. All right. Unfortunately, when you have a point like 1, 1, and 3, 3, where it's a diagonal line, or even more so a point like 4, 2 and negative 1, 4, where it's really a diagonal line, you have to use distance formula. And that formula obviously is written down there as the square root of quantity x2 minus x1 squared plus quantity y2 minus y1 squared. Once again, it does not matter which point is x2, y2, and which point is x1, y1. So if I made this x2, y2, I just got to make this x1, y1. That would be 3 minus 1, which is 2 squared, 3 minus 1, which is 2 squared, and we get the square root of 8. And if you can simplify it, you should do so. The square root of 8 is 2 root 2. If I put in 4, 2, and negative 1, 4, okay, we get 4 minus a negative 1, which is 5, and then 2 minus 4, which is a negative 2. 5 squared is 25, negative 2 squared is 4, and 25 plus 4 is 29. So your distance is the square root of 29. Now the distance formula is very closely related to the Pythagorean theorem. And that's something you've probably already seen before, but I want to make sure that we know it. Okay? If you think about it, any diagonal line, and if you took your graph and you drew on it, okay, and you drew a line from 1, 1 to 3, 3, it would be like this right here. If you created a right triangle, you'd go down 2 and you'd go left 2. And essentially, the difference in your x coordinates would be this distance down here. The distance in your y coordinates would be this distance right here. And it would create a right triangle. Every diagonal line can be the hypotenuse of a right triangle. So we can actually find the distance of a line one of two ways. We can use the distance formula, or on a graph, if you want, you can draw the line, create a right triangle, and use the Pythagorean theorem. Now, please make a note of this. All right, let's use 4, 2 and negative 1, 4. So here's 4, 2 right here, and here's negative 1, 4. If I draw this line here, I'm going down 2 and over 5. The Pythagorean theorem is not really a squared plus b squared equals c squared. It's more accurately the leg squared plus the leg squared equals the hypotenuse squared. So it's very important that you put the legs on one side of the equal sign, square them and add them, and that the hypotenuse is squared on the other side of the equal sign. Okay. Here are some practice problems. Okay, you can use distance formula or Pythagorean theorem. And I'm just going to do one. You can do the other two for practice, and we'll do them in class for practice as well. But if I were to do Pythagorean theorem, I would create a right triangle here, going down and then over. I'm going down 1, 2, 3, 4, 5. And I'm going over 1, 2, 3, 4, 5, 6, 7, 8. 5 squared plus 8 squared is 89. And the square root of 89 would be the length of this line. Let's do distance formula. Negative 5 minus 3 is negative 8 squared, which is 64. 6 minus 1 is 5, and 5 squared is 25. And 64 and 25 is the square root of 89. Now our other topic here is midpoint. And we'll talk about segment bisector as well. But the midpoint is going to be the key. The midpoint is a point that divides a segment into two equal parts. We can never assume it, but if it's told to us, then we can use the fact that if we have the midpoint, those two segments that are created, we can say are equal. Remember, we cannot do that unless we're told, but if we are told, we can set those segments equal. A segment bisector is whatever intersects a line at its midpoint. So a segment, ray, line, or plane that intersects a segment at its midpoint is considered a segment bisector. When you find the midpoints, okay, you can do it by counting, okay, or you can do it through a mathematical formula. We may be able to look at these lines and figure out the midpoint. In fact, this one I think is pretty easy. This midpoint right here is 6, 1. This one's not going to be as easy because the midpoint really doesn't land on an exact intersection on our graph. So that's why our midpoint becomes very important, okay? At this point, I'd ask the class, can you find the midpoint based off the picture and come up with a formula that would always give me my midpoint? So here's your midpoint formula. If you add the x coordinates and divide by 2, you get your x coordinate of the midpoint. If you add the y coordinates and divide by 2, you get the y coordinate of the midpoint. In terms of finding a midpoint, it's just 3 plus -1 is 2. 2 divided by 2 is 1. -5 plus 7 is 2. 2 divided by 2 is 1. So 1, 1 would be the midpoint here. You can try the second one on your own. If I'm given a midpoint and I need an endpoint, we will go through the math in class, but here's a quick way to do it. What do you need to do to get from 3 to 6? You add 3. Just add 3 to that 6, and 9 would be the x-coordinate of your other point. What do you need to do to get from -1 to -3 on the y side? You would subtract 2. So just subtract another 2 to the y-coordinate of the midpoint, and you'll get your other endpoint. -3 minus 2 is -5. So our endpoint is going to be 9, -5. I'll leave the last two for you to try, and obviously we will go over them in class as well. And then the last part, if you're given a midpoint, we can literally set each segment equal. If you're given a midpoint, if this is 7x plus 4, this is 7x plus 4. So we can double one segment and set it equal to the entire line. So this would become 14x plus 8 equals 16x minus 2. And this one right here, if AC is 46, that means both of these are 23. We can't set them equal because they're different variables, but we can set each of them equal to 23 and solve for y.